Right, here we go. Hello again, everyone. We're here for user satisfaction and dialogue breakdown session. We have our chair, Stefan, with us. Thanks very much for chairing this session today. I'll hand it over to you to introduce yourself briefly, and then we'll start with the first speaker.
All right, sorry about the delay. I had the YouTube stream in parallel running, so that was a bit distracting. So hello, everybody from my side. My name is Stefan Ultis. I'm at Mercedes-Benz Research working on our voice assistant, doing research on that degree. This session is about user satisfaction and dialogue breakdown detection. I think it's a very interesting and relevant topic because you always need to have an idea whether your interaction with your users actually work out well or actually do have problems. And today we will see or hear three different talks that target these different questions from different angles in different tasks as well. If you want to ask questions, feel free to use the YouTube comments. Also for the kind of panel section after the talks, where we might want to ask like overarching questions to all of the speakers. But now, without further ado, let's start with our first presentation, our first speaker, Shuo Zhang from Bloomberg. The stage is yours.
Okay, so thank you. So can you see my slides now?
Yep, all good.
Okay, thank you. So thanks for the introduction. Good morning, everyone. My name is Shuo. I'm working in the AI group at Bloomberg. And this work I'm going to present is a joint work with Christian Ballag from Universite of Norway, Vivi Joltron and the rest from Shannon University, China, and Martin from University Amsterdam. So this work is about evaluating task-oriented data system from the perspective of user simulation in terms of user certification. Okay, so broadly, there are three types of dialogue system which share very similar evaluation methods. So for task-oriented data system, they aim to solve a specific task such as booking flights and reserve a restaurant table over the course of conversation. And the dialogue here is you already have very clear defined structure that is driven from like domains. Conversational agents focus on like most unstructured open domain dialogues. I think they are designed mostly for enumerated social interactions. Also, interactive QA systems are built specifically for the task of QA. I think simulation here is widely used in the last case, mostly based on very simple heuristics and templates. And of course, the three, this work is focused on the first one is because the concept here, as I mentioned, is more structured and which is beneficial to like multiple turn simulation and also have a very clear and expectable task objective for evaluation. In terms of like evaluation methods, there are many different choices. Like for example, offline evaluation in information retrieval community has a long history where it's possible to create reusable task selection for a specific task, but problem is like it does not reflect the overall system usefulness and also the user certification. Instead, like human evaluation, no matter evaluate like certain aspects or like tell the overall user certifications over the course of no matter questionnaires or consortium tasks, it's possible to rate the entire conversation, but as you can imagine, so it's always expensive, time consuming, and does not scale. So instead, like user simulation, the idea is like to simulate user behaviors, and it has been used as the environment to train reinforcement learning-based system, and the evaluation here is purely based on reward achieved on the user simulation. So in our case, what we aim to explore is we want to use simulation as an individual component to evaluate like the overall, no matter one aspect, the overall function like system with a goal to find weakness, for example, and potentially replace human evaluation, not fully like somehow. So more precisely, what we aim to explore by this work is to investigate the way to bridge the gap between human evaluation and user simulation, as well as like user behaviors and user judgments, so that we propose the task of simulating user simulations where we incorporating like user certifications into the simulation process, where people usually like do simulation purely based on the action or intention or the intent label. More precisely, the simulation task now is focused on two prediction tasks, because this is the first step towards a simulator that we aim to build. So here is like component that have two tasks. One is predict the next use action. The other one is predict the next use certification. So given some context, like in a dialogue, for example, we aim to predict like next action as well as the certification. This paper is actually a resource paper. Here we introduce how we construct the dataset, as also this dataset is paired with some initial, I would say, very simple solutions or baselines. So firstly, I will just briefly mention how we construct this. We call it like USS, which is short for User Certification Simulation Dataset. And this is based on 5 benchmark task-friendly dialogue datasets. I think there's one thing I need to mention that, so here's the assumption that for our sample strategies, the usability of the system can be somewhat approximated by user certification of these users. So we consider like 5 datasets. One is GDDC, it's a real-world Chinese e-commerce conversation corpus, have over 1 million dialogues, and we classify this by the transaction types, 11 types in total. For example, some are asking for the like delivery status, or return the goods, or request the invoice, etc. Then we sample based on each type, have 3,300 in total, and the rest like schema guarded, wizard rules, or the rest of the 2 are mostly for conversational movie recommendations. This slide shows the annotation process. So we hired like 40 annotators to label each of the conversation, both on exchange label and dialogue label. You can see on the right side, there's 2, one is positive, one is negative peak sample. So each utterance or each turn, there is a rate, and after the conversation, there is a dialogue label rating here. And they were asked to rate this in 5 scale. For example, very dissatisfied or very disappointed means like the system don't understand the query, or even cannot meet the requirements. And then the degree of that, like across the scales, like the services or the replies improve with the change of the scale. In addition to this, we also ask annotators to give a textual explanation behind the rating. I will cover in the next slide to see what's the reason behind the ratings. This slide is like just show some statistics. I will just skip it for now. In terms of the baseline methods, we consider 3 groups of methods for now. One is feature-based models, where we consider very standard like features, including TF-IDF, for example. Also, the length of utterances and the position, for example. Also, no matter RN and BERT models are very similar. So what we do is we convert all the dialogue history into into 1 sentences, long sentences, then fit into these models for the prediction task. One thing I want to point out is we have 2 goals for the classification task: is next user action and certification. This table shows the user certification prediction results, and we report results on like for example, on weighted average recall and F1 scores. The point is, like, given one dialogue, we have multiple labels, no matter on the in the ground truth, also in the predict ones, because each term have a rating label. So the idea is that we compute the consistency or correlatedness between these two vectors. One is ground truth, one is a predict one. So based on the results, RN model performs slightly better. For user action prediction, so we report based on like accuracy, precision requirement, F1 scores. Here, BERT-based model perform best, I think. In addition to this, since we cover like multiple domains in this dataset, including travel and also movie, for example. And we here analyze the cross-domain generalization capability of this user certification. Let's compare just briefly the numbers. The first column shows we train based on this and then verify on the rest. So let's just briefly compare the numbers roughly. The first column, like the recall, it's actually comparable. This is give us a very good signal in the future for any new domains or any new data sets. We can potentially build a user simulator on top of this. So lastly, I want to bring your attention back to the data set. So let's think about the question on what courses use the discertification. Just overall, like 12% of dialogue turns are labeled as very disappointed. Just recall that we also collect the reasons when we ask the annotators to label this or to rating this. So, and we analyze this and find the main reason is because of system failure. In addition, like the system was not professional enough or did not respond like timely, especially when the user have very proper like request, for example, ask for invoice or checking the delivery states. So, and over the course of incorporating user certification into simulation, we now bridge these two together. So in the current like experiments, we deal with them separately. But how does user certification influence the user's behavior? Based on the dataset, we found that different degrees of certification reside in different sequence of use actions. And in specific, when encountering a failure, like in a dialogue system or understanding the user needs, about 17% of them will switch to menu customer services. And about 65% will continue the conversation, but providing more context, or some of them, the 10%, will terminate the conversation. So come to the question how we can use the resources. In addition to improve the model, it actually also comes close to the question or problem of like natural language response generation to reflect user certification. Also, we can take the ground like to incorporate external knowledge and personnel in addition to user certifications. Also improve like dialogue breakdown, also interpretability studies for evaluation. These resources have been open source. Please find this from this link. Thank you for your attention. I'm happy to take questions from now.
Thank you very much, Shuo, for this very interesting talk about user satisfaction-based user simulation. We will probably leave most of the questions for the panel later, but I have just one quick one. The dialogue you showed, the example one on the left side, which was successful there, I had a question about a specific rating, where is the third one, which is only 2 stars, the left side. And I was wondering whether you have insights why this is, because from my point of view, the system was actually quite reacting quite reasonably.
I think this because based on our design of the scale, I think the 2 stars means like somewhat okay. The system understand it, but it does not solve the problem directly. If it's an indirect way, we give it like 2 stars. The 2 star does not mean like very disappointed actually at this point.
Okay, but I mean the system actually did did cancel. Anyway, I was just wondering when I was looking at these dialogues and wondering about the consistency of the data set you are.
I see a point. I see a point. Probably like the 5-star correspond to this one. I mean the illustration like it's a bit like confusing.
Okay.
Yeah.
All right. Let's talk later. Thank you again for this interesting presentation. And let's move on to the next presentation from Leon-Paul Schaub from Universite Paris-Saclay. I hope I pronounced that as well correctly. The floor is yours.
Yeah, correctly. Can you see my screen?
Yeah, all good.
Okay, thank you very much. So, hello everyone, thank you for being here. I will present our work defining and detecting inconsistent system behavior in task-oriented dialogues. This work was a collaboration between the Paris-Saclay University and the Charles University. So, according to a well-accepted task-oriented dialogue model, a dialogue can be defined by a task, which is the purpose of the dialogue, domains that are for example, restaurant table booking, hotel reservation, car rental, a success, that is both the task fulfillment and the dialogue continuity and the end of the dialogue, and turns. And turns are composed of utrons, which is what the speakers say, whether it's the user or the system, and the inconsistencies, that is weird stuff found in systems utrons. There is also dialogue acts that describe the utrons with intents, which all show the intention of each speaker, and slots that characterize the intents, and finally errors that show that the system cannot fulfill the user's desire. So to be more specific, what's the difference between an inconsistency and an error in a dialogue system? So an error is situation-based, it's contextual, as I just said, is the system that cannot fulfill the user's desire. For example, if the restaurant the users wanted is full or closed, or simply that the system got mistaken when doing a reservation. It's a human-like mistake. It's something a human could do, and it only affects the task success. Whereas inconsistency is language-based, is semantic. It's something weird found in the system utrons. It's something a human wouldn't say, something the user finds odd, and it could directly affect the dialogue continuity. So we decided to establish a typology of the inconsistencies inspired by the DSTC2 dataset. And we found 5 kind of comprehension-related inconsistencies. The first one is the intent that was misunderstood by the system. The second one is when the intent is understood, but there is a bad slot, a bad entity. And finally, thirdly, the by misunderstood. It's a kind of special intent misunderstood when the user wants to end the dialogue and the system doesn't understand it. Then you have full language used by the user. It generally means that the system said something annoying and something it shouldn't have said. And finally, the negation error, when the system doesn't understand that the user negates an intention or a slot. Like in this example, like when the user says no French food and the system thinks that the user wants French food. Then you have the dialogue management related inconsistencies. It's when the system does a bad API call, for example, to find for information in an external knowledge base. The DSTC2 allows us to have access to the API calls made by the system, so we can check whether it was a good or a bad one. Then you have the repetition, when the user is forced to repeat twice the same utrons across the dialogue, twice or more times actually, and it usually means that the system said something it shouldn't have. And finally, you have the incompleteness, like when the user asks for 2 or more information and the system only provides 1, for example. Then we established a correlation between these inconsistencies and the dialogue failure. In the DSTC2 dataset, we have the annotation whether a dialogue is failed or not. So we decided to build a model being able to predict whether a dialogue is fail or a success. And we found that by adding the features of the total inconsistency number and the inconsistency happening before the API call I just mentioned, we are able to predict more precisely whether a dialogue is failed or not. So then we focused on the inconsistencies and the information management for the dialogue system, and we found two leads. The first one is the dialogue history, relevant information. Several studies show that most models struggle to deal with long dialogue history across the response generation, mostly because too long dialogue history becomes noisy especially the first speaking turns become obsolete. Then we just said that, for example, in the repetition case, we need to know that the user said twice the same thing. And therefore, we thought that with the next user's turn prediction, we were able to detect more precisely whether there is an inconsistency in the system's response or not. Several studies already show that the next user's turn prediction could help either the dialogue act prediction or the better dialogue state tracking. As for the annotation results we made of inconsistency in DSTC2, we used a rule-based model based on the 8 types of inconsistencies we described. The rule-based model achieved 80% of accuracy after human evaluation, and we detected that 87% of the speaking turn do not contain any inconsistency. So for the experiment and baselines, we use the BLSTM with attention, the dialogue intent entity transformer classifier from the Rasa framework, the WM2SEC, which is a memory network-based model, and the GPT-2 transformer that showed already good performance on several dialogue-related tasks. The results show that the GPT-2 outperforms all the other models with 99% of accuracy and F-score, almost solving the task, and doesn't benefit from shorter dialogue history, neither from the next user's turn, whereas the WM2SEC does benefit from a short dialogue history and the next user's turn. So in conclusion, we built a new dataset based on the DSTC2 corpus with annotations for detecting dialogue inconsistency. Our experiments revealed some correlation between the system turns inconsistencies and the dialogue failures. We used 4 different methods to detect the inconsistencies. The best performing models were the GPT-2 based one with that strongly benefits from the whole dialogue history, whereas the WM2SEC perform best when there is no history and when we use the next user utrons. So in general, the next user utrons improve results across the board, but we think we need for a more efficient way to filter the dialogue history to improve results for the non-pre-trained model-based methods. And instead of an oracle, it would be more interesting to train a model to predict the next user's turn instead of having it given. And finally, for the limitations of this work, it only works for human-machine dialogues and therefore for human-machine dialogue datasets. And it wasn't tested on a bigger or more complex dataset.
Great, thank you very much for this interesting presentation about a more fine-grained look at why dialogues succeed or don't succeed. I think that's very, very interesting work. We have one question in the chat, but I think we can quickly look at, which is whether this approach can be used to detect inconsistencies in other dialogue types, for example, conversational recommendation or anything like that.
Yes, absolutely. We tested on restaurant reservation domain, but it's possible that due to the typology we made that is quite general for the inconsistency, we could adapt the rules for annotating another kind of dialogue and therefore predict the inconsistencies.
Thank you. So as with the previous talk, let's keep the remaining questions for the final panel. So we move on to our last presentation of this session. Let's welcome Katsuhide Fujita from Tokyo University of Agriculture and Technology. Stage is yours.
Thank you. So, okay, can you see my slide?
Yeah, all good.
Yes. Okay, thank you. So today I'd like to talk about the dialogue act-based breakdown detection in negotiation dialogues. I'm Katsuhide Fujita, Tokyo University of Agriculture and Technology, Actually, the first author of Atsuki Yamaguchi should make the presentation about this research, but he had some tasks, so I make a presentation on behalf of him. Firstly, background. This research is focused on the negotiation. Negotiation is an essential task, and the studies of negotiation dialogues get attention recently. And negotiation is one of the goal-oriented dialogues, and also some data set for the negotiation dialogue is proposed, such as deal or no deal data set or Craigslist bargain data set. And also, if we can achieve some dialogue, some studies about the negotiations, we may support the human and human negotiation, such as try to find the good agreement point, or sometimes real-time negotiation coaching or ETO. Therefore, we focus on the negotiation tasks. And after that, I'd like to talk about some problems and contribution of this research. One of the big problems of our research is the few negotiation dialogue corpus. The existing corpus was the deal or no deal corpus and Craigslist bargain corpus only. And also, their negotiation settings are very simplified. And also, some other corpus is too small to use. Therefore, it is hard to use them to do the deep-learning or etc. Therefore, and also, another one is about the negotiation breakdown detection. There are no effective method has been proposed. Therefore, firstly, our research focus on the developing a new negotiation dialogue corpus. We call job interview dialogue corpus. And also, we propose a dialogue actor-based feature. This is a new method, new approach with a machine learning model for negotiation breakdown detection. So firstly, I'd like to explain about the job interview negotiation data set. In this dialogues, there is one scenario. This is a job interview between two negotiators in English. And they are negotiating about the job interview. And also, they talk about the like salary issues or weekly day off issues or position, company, and workplace issues. And in ETC, you have some options such as the salary option. Salary issue has the $20 to $50 per hour option, etc. And in the negotiation dialogue, usually this is a very simple negotiation, simple dialogue such as hello, hi, I have a position open as an engineer at Google. Are you interested? Yes, I'm interested in it, blah, blah, blah. And like this data set, we generate using the Amazon Mechanical Turk. And also, each negotiator have some utility or preference about the each issue or option. This preference is predefined by us to the each negotiator using this equation. And this is a statistical result of the job interview negotiation dataset. Negotiators in the GI dataset likely had enough conversation using this result. And also agreement ratio, this is it means the success of the negotiation rate is a huge gap between the GI and others. It seems that the GI dataset is likely to make agreement. And also, about the complexity of the negotiation scenarios, our proposed GI dataset is a little bit hard, more complex, because GI our dataset has a fewer optimal solution. We call this is one of the important solutions in the negotiation research, but this is a far fewer. So the reason is firstly the large number of the possible solutions per dialogue exist, And also, we introduced some interdependent issue relationship. Therefore, the complexity of the negotiation is higher than the other dataset. And after that, I'd like to talk about the negotiation breakdown detection task. This task is firstly given a dialogue composed of many turns between two negotiations. And also we propose a model, and which model needs to classify whether its outcome is successful or not. For example, there is some negotiation dialogues. And this our model can detect that this negotiation is the breakdown or success using the negotiation dialogue. And usually, successful version is they reach some agreement, such as I want to rent one, and how about the $5? I need at least $7. How about the $6.5? And okay deal. In this situation, is that they can make the agreement. But for example, like this situation, they break the negotiation. So in these situations, they talk about the salary or workplace, and finally, sorry, we can't rise the on hourly rate anymore. And finally, other negotiators say, okay, maybe next time. This is the breakdown negotiation. So our model automatically detects this success or breakdown situation. And our approach is that we propose a dialogue act-based features with machine learning model. This is from the intention that the breakdown dialogue should have the distinct flow. And the pipeline is firstly, our method model extract the dialogue act in the utterance based on the matching patterns, and align and filter the extracted dialogue acts according to the constrained negotiation flow, and also concat the all filter dialogue acts. Firstly, we do the get some dialogue acts like these tags from the pattern matching method. I think this is a very simplified method, but we can get some important dialogue tags from the dialogue dataset. And after that, we do some filtering and arranging. After getting some important dialogue tags, we arrange these tags and generate and also compare this constructed flow of each dialogue turn. And this constructed flow of each dialogue turn is the design proposed by us, and only compare this this flow is on this dialogue flow or not. By using this one to reduce the detection noise caused by the rule-based matching, and also this one is inspired by some negotiation theory. And the final one is the concatenate extracted features and create a single sequences. Instead to the special spoken separator tags, and using some linear model or some neural net based model, and also detect that this negotiation is a success or breakdown. And there is the experimental settings. We use the dataset, deal or no deal, Craigslist bargain, and job interview dataset. Also, we compare some classification models like this one. And also, we use some data processing, and model training and testing is like this one. And also, evaluation metrics, we use the ROC-AUC, confusion metrics, and average precisions, and mostly follows our previous works. And lastly, into the summary is the GR-based model trained with the dialogue act-based feature. This is our proposed approach, perform well. About in the existing datasets, our proposed approach shows a similar result over the model with the textual features. And also proposed dataset, GI dataset, we can achieve the better result. And achieve achieve the result. And we analyze using the ablation study, and we understand our proposed methods the agree and propose and disagree and inquire tags are important for detecting this result. And also agree, disagree, and disagree, agree, like these tags are very important for detecting the result, detecting the breakdown or successful the negotiation. Here is a summary of our research. And future work is that we would like to explore the application of dialogue act-based features, and also we like to utilize the proposed corpus in the related tasks. Thanks very much.
Thank you very much for this interesting talk. There are actually 2 questions, and I think we have enough time for that. First one is, how does breakdown in negotiation dialogues differ from breakdown in task-oriented dialogues?
Yes. Yes, this is a task-oriented one. Yeah, because all negotiators or participants want to make the agreement, usually.
Okay, and the second question is, would your dialogue extraction method be applicable in other domains or other types of dialogue? How hard would it be to adapt it?
Recently, we started like a study about this one. And also we can use the fine-tuning methods or transfer learning methods. We can adapt the other domains. But without that, it is a little bit hard to achieve one.
Okay. All right, thanks. I think let's start with the panel discussion. Looking already forward to your answers. And I would start with the first question, which kind of targets the different ideas behind your approaches. Shuo was looking at user satisfaction. Leon Paul was looking at inconsistencies during the dialogue, which is in some way, even though it does correlate, it is independent of the task of looking at the outcome of the dialogue. And then Katsuhide was looking at a breakdown, or if you want to say the opposite, success. And I was wondering whether all those 3 things are basically different sides of the same coin, or where you see the differences and the things that actually are common for all of your ideas and approaches. So who wants to start? Or I can also call somebody out. That's fine with me. Sure, you're smiling. That's usually not a mistake. And you're the first.
I have an opinion about user satisfaction and inconsistency detection. Not that much for negotiation dialogue because I don't know that topic that much. But in our data set and in other data sets, you could correlate the dialogue success or failure with the user satisfaction. It's not a very good metric, and it's not as well described as in the Paradise protocol of dialogue evaluation, but still the dialogue success could be correlated in a way with the user satisfaction. So if you consider that you correlate also the inconsistencies with the dialogue failure, in a way, in an undirected way, you could correlate these inconsistencies with the user satisfaction or not. Obviously, in our work, we didn't do the user satisfaction, and in Shuo's Zhang, there was not actual inconsistency detection, properly speaking, but it's not crazy to believe that we could do some work to correlate both facts.
Yeah, I think I agree with Leon, the fact that, to also come to the first question, I was asked about the data inconsistency when you check the rates in the example I showed. This is because in the annotation process, what we did is like, we are not give a reply or utterance to ask the annotator to label them. Instead, we just give the history, like dialogue history, let the user to predict what is the next action and what is the next user certification. It is closely to the question like how dialogue success will affect the both actions and the ratings, because we do see like I wouldn't call it like inconsistency. People tend to show different like attitudes towards like user certification and success rate or dialogue success. And this is also something we want to simulate, because we do want to see like a variance. We don't want people tend to all show the same thing or attitude, the same like user certifications.
So based on what I understood, you're basically saying it is those are different sides of the same coin. They do complement each other, or they do represent similar things, but are just executed in different ways in your specific works.
The inconsistency is not an evaluation, whereas I think user satisfaction is. So the inconsistency is a feature. It's something you could label an insurance with, whereas user satisfaction, I think it's not only limited to one speaking turn, right? It's a more general metric. So obviously it's close, but I wouldn't say it's on the exact same dimension. It's not exactly the same kind of object.
But I have a question, like, what do you think, like, how the system, dialogue inconsistency will affect the fact that people will turn down the dialogue? I mean, let's say a better user certification, also system success or inconsistency, all these factors will affect the user's decision if they want to continue or they want to break down the dialogue. I think those are all the factors, but definitely different aspects.
Absolutely. And there is something we didn't measure that I think it could be interesting too, is the attrition risk, is the fact that the user will never come back and will also provide a negative feedback for other users not to use the dialogue system, for example. That's something we didn't study, and in future works it would be interesting to correlate both inconsistency, user satisfaction with the attrition risk.
Katsuhide, when you look at your work on breakdown detection for negotiation dialogues, what would you say about satisfaction and inconsistencies and how that reflects on the breakdown detection task?
Actually, I think this is a yes, because one of the important aspects of the user satisfaction in the negotiation is firstly the dialogue, the inconsistency, and also some smoothness of the dialogues. This is related to the inconsistency, and also I think that usually users have some expected dialogue flows, and also this dialogue is follows this dialogue flow. Therefore, I think yes, this question. Yeah.
Cool. Maybe let's move on to a rather different question, which was actually added to the YouTube comments. What is your opinion about how difficult it would be to transfer your approaches on task specific dialogues or on negotiation dialogues to more open domain dialogues, chit chat, social interactions? What would you say would need to be changed, or what could remain the same? For example, you could imagine that you could also kind of figure out a way of breakdown of the conversation, not only for negotiation dialogues but also for social interactions. So, what would you say? Could you transfer your ideas and approaches to the domain of the broad theme of open domain chit-chat conversational dialogue systems?
I can speak first. So I think from the perspective for evaluation, I think for user simulation, also certification simulation, Probably it is difficult to transfer to open domain or cheat, because here the goal is we aim to simulate a user which has a clear goal that is the user has like a very clear and expectable objective over the course of conversation, not just like a cheat. Probably if we can find a way to formulate the goal, it's likely, but I probably think it's less likely.
Katsuhide, do you have a comment on that? About the general question of how...
Yes. Yeah, actually, mainly I agree with that. For example, my judge is about the negotiation, and the negotiation is goal-oriented. But for example, this becomes an open domain, and goal is a little bit changed or some other goals. Our approach is very hard to apply. So a little bit hard to do the open domain to our approach and also other approaches.
Leon, you wanted to say something when I...
No, I said I agreed with Shuo, and now I agree also with Katsuhide.
Okay, so you're basically saying that, in summary, the variations you would see from the user judgments would be so subjective that you would not be able to have like good annotation set that could be then in any way, in a meaningful way, be used to do any of the things you were doing with task-oriented interaction. Or is this just my interpretation?
I think it's like transferred into like cheat instead of task-oriented data system. I think the variance of the annotations be meaningful because we do want to like rely on the variance to have a difference. For example, evaluations, detections, etc.
Okay. No, I'm not sure I understood.
Yo, I mean. So I think because in your last statement you say, okay, the variance of the annotations will be hardly used to task-oriented dialog system. I mean, I just trying to correct the sentences. That is, it's probably hard to transfer to cheat, not task-oriented dialog system. Yeah.
Now it makes more sense. Yeah, I absolutely agree. I mean, that was a mistake from my side. So okay, cool. So we are all agreeing on that. Very good. So there are other questions. Let me just check that. There's a question to you, Shuo, whether the satisfaction level would be different when rating the dialogues at system or user utterance. So in your work, you were annotating after each system response, right? And I think the question is whether it would be different whether you rate after system response or after the user utterance.
You mean like if I change the sequence, right?
Yeah. I think if the ratings would be applied at a different point in time, but I'm just interpreting the question I see in the comments.
Okay,
that would be my interpretation.
Okay.
For example, with the interaction quality, the work I was involved in, we did annotate after every user utterance, right? So basically representing system point of view, the system would receive a user utterance, and then it's okay. System can assume this is the satisfaction level at that given time.
Yeah, I think. Well, so yeah, this question is still a bit confusing for me. I think what she's asking is like, will be the certification be different when we rate like on the exchange level or based on the history or the entire dialogue, right?
I think it's rating the dialogues at the system or the user utterance. So I think right now you're rating the satisfaction ratings for each after each exchange happens after each system response, right? Then system response, then the annotators were asked to apply a rating.
Correct.
But this could also be, you could also apply the rating after each user utterance.
Yeah, but we do it in a formal manner. just to simulate, well, just to make sure in the annotation process, we also kind of simulate the users, because like the annotators are not the real users in the conversation, or the actual users.
So you're basically saying that there would be a difference.
There will be a difference, but we actually keep an eye on this, but we would prefer to have a somewhat agreement, and the variance will reflect on like the sequence of actions, yes, or over the course of conversation, instead of like the certain exchange.
Yes, I think it's given by the task that you want to do the user simulator, so you need to model the user perspective basically, and then it's important to model the user satisfaction level once there is before it's the user's turn, basically.
Yes.
So the user makes a decision on how to proceed. I think it's
correct.
Given by the task, and you cannot just exchange it.
Yeah, correct.
So there's another question also about the applicability of these to other types of dialogues, like whether it could be transferred to conversational research or conversational question answering, and also whether job interview is an information seeking or a negotiation dialogue. But I would say, since we're already a bit over time, I think if you want, you can answer those questions in the comments directly. And I think the session is over, and the next agenda point, if I'm not mistaken, is the poster session, Lee.
Yeah, so thank you again. Another great session this morning, or again, depending on what time zone you're in. Thanks to all our speakers. Thanks to the great panel discussion. Thanks, Stefan, for chairing the session. Yeah, we have a quick break before the poster session, then followed by a lunch break. The next broadcasted paper session will be at 2 on dialogue personalization. I believe Svetlana sent around the links for the poster session to everyone. So look forward to seeing you there in Gathertown with little computerized avatars. So thank you again. Thank you for all the questions in the chat, and we'll see you at the poster session.
Thank you.
All right.
Thank you very much.
Thank you.
Bye all for now.
Bye.